Okay, so next up we have Adam Retter from Evolve Binary. Please take it away.
Thank you. Hello everybody. Thank you for attending my talk. Maybe you don't have a choice, but hopefully it will be interesting. So, a little bit about me, but the interesting thing really is, if you don't know the XML Summer School, this is a bit of a plug for it. So there's a wonderful conference in Oxford in September. It's a week-long kind of XML camp, part training course, part conference. I suggest looking it up if you're into this kind of thing. So. Okay, well actually that's quite relevant because my talk is actually about that kind of thing. So this poor little chap here, you probably can't read this, but it says, after trying to fit together 3 different incompatible sizes of Lego, Leon went into meltdown, not quite grasping the problem. And actually, I feel like that quite a lot. And I'm probably 30 years older, maybe more actually. But it should be simple, right? I mean, somehow there's a problem with technology still. And it gets to the point where I go for 4 or 5 years, and then I get annoyed, and then I give a talk on it. So this is a talk about me being frustrated about something. So, okay. So I think there's a portability problem with XPath-derived languages. I'm going to sort of look at what else has been done in this area. You really need to read the paper on this if you're interested in it, because there's more detail than I can possibly get into in this short talk. I'm going to look at what XPath, XQuery, XSLT processes really exist in the wild. And then I've got a kind of crazy idea about how I might solve this. And it's pretty crazy. So let's see. I get quite tired saying XQuery, XSLT, XBlock, XForms, so I've coined the term XPDL, XPath-derived language. It's not necessarily just those, there are probably others, but I'm basically saying something that uses XPath functions and operators as its standard library, okay? And there's some XPath in there. So maybe your host language is Java and you're using XPath, I don't know. But, okay, so I'm at an XML conference. I'm going to assume that some of you want to write your applications in XML. There are some very good reasons for that. I'm not going to tell you what they are because you're all here, so I guess you know. If you don't, you can certainly go and look at this paper from 28MSec that's quite relevant about processing data with the same data model as your programming language and your data, so you reduce the impedance mismatch between code and data. You can make some real savings in efficiency and time. So I'm afraid I have quite a lot of slides to get through and not much time, so I might be going quite quickly. So the portability problem, as I see it with XPath-derived languages. Typically, these things are based on open standards. As far as I know, they're all from the W3C. So we have these wonderful, pretty long standards documents. They're mature. For example, I think XQuery 1 took maybe 7 years, possibly longer. XQuery 3, which wasn't meant to take 7 years, I think took 7 years. And XQuery 3.1, which wasn't meant to take 7 years, took 2, maybe 3 years. So it's getting better, but a lot of thought goes into these things. So they should be pretty portable, right? They're open standards. However, if you write in the real world applications in XPath-derived languages and you try to run them on one processor, and then you take your standard code and run it on another processor, you might not get the same result. In fact, it might not even compile, or not compile, but be interpreted perhaps. There is a real portability problem. So we're going to have a look at why that is. So this is fun. Vendor extensions are evil. So XQuery's standard library, or XSLT, or XProc, or an XPath-derived language is based on the function operators spec. And we try to do that at a very high level, but really that means that we avoid talking about the real world. Particularly I/O, because as soon as you have to interact with the real world or a system, things become very, very messy, and it's almost impossible to write a standard for this because every system is different. So vendors come along, and they have a need from their customers, they want to do something, and so they create some extensions to do this, and this is great. And the worst way that this is done, but also the most useful, is extension functions. Okay, so I think MarkLogic's standard library is hundreds, maybe thousands of extension functions these days. Exists is something like 55 modules of extension functions, probably in thousands now as well. But every one of those extensions functions is specific to the platform that you're running on. Okay, so the exist ones are specific to exist. The MarkLogic one's specific to MarkLogic. Saxon has a few specific ones, not many, which is good. But if you use those in your standard XSLT, which is specified by W3C, or your standard XQuery, and then you try to run it on a different platform, it just doesn't work, right? Those functions don't exist on another platform. So my open, standardized code is no longer portable from platform to platform. And that's not really very good. Okay. So extension functions are particularly sneaky because they have a standard interface. Okay, XPath defines a function call interface. So it doesn't define how you're going to implement a function. There's no way of implementing a function in XPath. But it does define how you call a function. So you can go and use these extension functions in a standard way, but you can't move between platforms because they're just not present on all platforms. So typically people distribute these throughout their code base. It's entirely valid XSLT or XQuery or XProc, but it's not portable. Okay? And I think portable is a really important thing. And there's a real reason for that, which is that, okay, sorry, that's in a slightly later talk. I'll come to why portability is so important in this community particularly. But I did a little bit of sort of crunching. So I took some projects written in XQuery, I converted them into abstract syntax trees, and then I mined them to find out how many non-portable extension functions they call. So this is by lines of code. So we've got an XProc implementation in XQuery, we've got an XML editor, we've got a test suite. So this one runs on MarkLogic, this one runs on exist, this one runs on MarkLogic, this one runs on exist, this one runs on baseX. Okay? And they all use specific processor extension functions. So I can't just take one of these XQuery libraries and use it on any XQuery implementation. It's a problem. So what I wanted to know is, if you have a large code base, do you typically have more extension function calls? And there isn't a direct correlation, but certainly the external function calls, the blue bits, these are the non-portable bits, okay? So typically more lines of code, yeah, you're using more external function calls, but it's not like, this one should be out here because there's more lines of code. It's just generally bigger, but not direct correlation. And then I kind of wanted to know, were they distinct? So are you just calling the same external function call over and over and over again? So it's really only one function call to the problem, or are you using lots of different external functions from that platform? So I started looking at the distinct ones. The distinct ones are in yellow. If you remember, actually XProc XQ was the biggest code base, but it uses relatively few external functions. Well done, Jim. Whereas Xide, smaller code base in XProc XQ, but uses far more processor-specific functions for whatever reason they felt they needed to do that. Okay, so the problem, I think, with portability in XPDLs is the XML community is relatively small, and it's a nice community. But it's not the Java community or the C++ community. If you go to a JavaScript conference today, there wouldn't be a room this size. It's going to be a massive hall with thousands of people sat there, all drinking the same Kool-Aid. So we're a very small community, but actually the fact that my code for Exist or MarkLogic or Saxon doesn't run on other processors just further fragments this small community into smaller silos. It's very sad, right? I can't write a framework like XProc XQ, publish it on GitHub, and all of my XML buddies can use it, because you're all using different processors. So some of you can use it, some of you can't. Some of you might spend some hours porting it or not, but then how do you maintain those two things out of sync? It's all very sad, really, and it upsets me. So I think we need to do something about this. Okay. So the first thing when I approach a problem that I really care about is I tend to look around and see what other people have done first, so that I don't turn up at a conference and someone goes, have you looked at this other project? Because that's always very embarrassing. So there have been some efforts in this area, and I have to thank Michael Kay for the XSLT 1.1 link because, frankly, it was before I got into XML. So I had no idea that XSLT 1.1 even existed. But it did something very, very, very interesting, which is it tried to solve the problem of extension functions. And its stated goal was to improve style sheet portability. Okay. So they added an element to XSLT called XSL script. And it's basically what it sounds like. It's almost like a script tag in HTML. Okay? So you could open up this XSL script, and inside there you could implement your extension function in the style sheet in JavaScript, ECMA script, or Java. So that's really interesting, particularly because your extension function is shipped inside of your XSLT. So you give this XSLT to someone, it's got your extension functions in it. Right? You don't need anything external, it's just going to work. However, not everybody thought this was a great idea. And again, very much credit to Michael Kay, and I've referenced this in my paper. There are several really interesting sort of flame wars that you can go and find on mailing lists from around this time of two distinct camps. Some people saying, this is great, and other people going, oh my God, kill it. And it was highly contentious to the point where it was abandoned because I believe the working group at the time couldn't basically agree to proceed with it. It's kind of sad. I mean, at the time, nobody knew JavaScript was going to take over the world. So, everybody wanted it to be their favorite language. Why JavaScript? Why Java? Why ECMA script? Why not Python, Perl, whatever? If they'd just done JavaScript, everyone would probably be quite cool about that today. But we didn't know. So that was really interesting. Then we had EXSLT. It's kind of nice. They came along and they said, actually, the standard library in XSLT 1 isn't enough. We need more, people need these extension functions. So we'll write a specification that describes a whole bunch of extension functions, and then we'll really hope that each vendor goes and implements them. And it worked, really. It was quite a success. Most vendors did go and implement these extension functions. It was a fairly small library, which helps, I think. It's not a lot of work for vendors. And then you could write XSLT with calls to EXSLT functions, and it would work on most processors if you're lucky. Not all, but most. So that was quite successful, really. Then we had FunctX, which is kind of different because they created an additional standard library, but it was implemented in XQuery and XSLT itself. So the extension functions weren't dealing with external I/O. Okay, you didn't need some higher level or lower level language to implement these things. But it was a very useful library. It's packaged with a lot of XPDL processors, and it's still widely in use today. Then EXQuery came along. So far, they haven't done a great deal. There's one specification which is about how you get XQuery to talk on web servers to the web, basically. It's okay, but it's kind of portable. Okay, it's a specification. Anybody can go and implement this. They also tried to produce a common implementation, but it's in Java. So if your XPDL processor is written in C++, I'm afraid you can't help. You're going to have to go and write that again yourself. Not ideal, but maybe everyone's using Java. Probably not. EXPath came along subsequently. Again, a little bit like EXSLT. They're very, very good at saying, okay, we need modules of external functions. We want them to have the same names, the same arguments, the same signature on every processor. So we'll create a specification. But a specification by itself isn't enough. Not every vendor is going to implement it. So they recently did a module for files. Okay, so you want to open files from the file system, manipulate the content, and process them. And I think there are 3 implementations of that standard. So I know BaseX implements it. I know Exist has a partial implementation. I don't know if I think Saxon implements it. But MarkLogic doesn't. I don't know if Calabash implements it. No? Okay. So there are lots of XPDL processors out there, and unless they adopt these standards, and they have to do work to do this, right? Someone has to sit down and implement this thing. It doesn't necessarily gain traction. It helps, but it's not a silver bullet. So what did I learn from looking at these efforts? Yeah, okay, standards are really nice. You have to have them, of course, that's the starting point. But unless you can basically get a critical market share, and I don't mean 9 out of 10 processors implement it, I mean the entire market, whoever are the biggest vendors implement this thing, and your code is still not portable, okay? So if you can't get the biggest market vendor of xQuery, for example, to implement a standard, there's a whole bunch of code there in a community that can't be shared with the rest of the community. That's a problem. So also vendors can be lazy. So standards are usually retrospective. Okay, rarely, sometimes actually, people sit down and write a standard before they realize they need a standard. It's normally a whole bunch of people have done stuff, it's different, and so somebody goes, oh, we should standardize this. The problem is a whole bunch of people have already done it. So you create a standard, and then it's very hard, after having created the standard, to convince people to implement the standard because they already have their own version that's slightly different. It's more work to basically give their customer the same thing they've already got, and that doesn't pay anybody's bills, rarely, anyway. So the XSLT 1.1 thing that was cancelled, the really interesting thing is it specified an implementation type mapping. So it basically describes how the types in the XML data model are mapped onto JavaScript types or Java types or ECMA types. Very, very cool. But it didn't succeed because it wasn't language agnostic, okay? Everybody wanted their favorite language. They were only going to do 3. People got upset about this. And there's no single language, okay? If you say, we're just going to do it in Java, you're going to upset a whole bunch of people. Everybody wants their favorite language. So I had a look at some XPDL processors. There's BaseX, Exist, Saxon, and Xkiller. The first 3 are in Java. The last one's C++. It turns out that function call in all of these, and this is the signature for function call, is almost the same. There's a context and there's some arguments. Okay, who would have thought you're going to call a function, you want some context and some arguments. But everybody is different, but they're the same. Okay. So what I really want to do is create an extension function in XPDL for XPDL processors that will work on any platform. Okay. So what platforms are out there? I did a little survey. It turns out the popular ones are C++ and Java, but there's a whole bunch of other stuff going on as well. So this is quite, if you look in the paper, this is all referenced and it goes into detail. This is just a very simple graph from that paper. So there's quite a lot of variety to cope with here if we're going to try and implement something that's going to run on any platform. So we come up with some requirements. I'm starting to go a bit quicker because I know I'm running out of time, I'm afraid. So I don't need to worry about standardization. EXPath is doing that. The W3C are doing that. Okay, that's not my focus. What I want to focus on is implementation. So I want to write an extension function that you can call from XPath, XQuery, XSLT, in some language. And I only want to write it once, and I want everybody to be able to use this, no matter if they're in C++ or Java or Linux or Windows or what. That's pretty broad requirements. It's going to be tough, or so I thought. So how did we solve this? So first of all, we need some sort of implementation type mapping. I don't know what my target is yet, but I know my source is XML data model, okay, the types from XDM. So I found something that would do this magic, basically. I just Googled. Impossible problem. And it turns out there is a solution. So there's something called Haxay. And Haxay is 2 things, okay? So Haxay is a source-to-source compiler. And it's also a language. So you can write something in Haxay, and it has a very extensive standard library of its own, written in Haxay also. And then you give it to the Haxay compiler, and it will compile it to your target platform. It will produce C++, Java, C#, JavaScript, PHP, C. There's a lot of targets for this thing. And it's actually been around for a while. And I'd never heard of this thing. It's fairly robust. Amazing. So we found some magic. So we then took our idea of an implementation type mapping. So we mapped XDM types into Haxay interfaces. Haxay is an object-oriented programming language. It also has some functional stuff if people are into functional programming. But that actually wasn't enough because we want to be able to implement functions, and XDM doesn't really describe a function call or a function implementation. So we started looking at the specs. XPath very clearly defines a function call. Doesn't define an implementation, so I just took the one from xQuery and modified it slightly. Okay. So we created a whole bunch of interfaces describing how you may produce a function. Okay, and this is it. So this is my implementation type mapping. This is Haxay, okay, the language. So if you know the XDM, we start with an item, there's an AEA type, there's an AEA atomic type. And to start with, I just did two types. So I have a Boolean and I have a string. And that's the real code that compiles to Java, C++, all of this. Now, obviously, there's a lot more types in XDM, but my slide is very small, so I can't put them all on there. How many minutes have I got, Charles?
About 6.
Right, okay, great, thank you. So we have some XDM types that we've mapped into Haxay, and we also need our function implementation type mapping. So here's a function. A function has a signature. And if we look back, or we can remember back to the slide where I showed with basex and exist and Saxon and xkiller, their function signature evals are all very similar. You're going to take some arguments, and you're going to take a context. Okay, and I can express all of this in Haxay. The other stuff is pretty standard. Okay, so a function has a name, a return type, takes some parameters. Okay. So this is cool. I've created a very abstract idea of the XDM type mapping and function interfaces in Haxay. But it doesn't do anything, okay? So what I really want then is I want to sort of say, okay, if the EXPath specifies a extension function that you should be able to use from any XPath language, I should implement that in Haxay, okay? Because the problem is at the moment, exist go and implement this, Saxon go and implement it, basex go and implement it, and we're all writing the same code over and over again to give to our users. It's a problem. So I took the EXPath file module and I started implementing it in Haxay, coding it to the implementation type mapping interfaces that I wrote and my function call interfaces. To start with, I've just focused on one function because I was very limited for time, I'm afraid. But it works, okay? And theoretically, it will run on any processor that will talk to my abstract implementation type mapping, which can be compiled to C++ or Java or C#. So, well, a whole bunch of other stuff as well, JavaScript, PHP, but this is kind of interesting. So here's my implementation of the file exists function. Eval is the interesting thing. This is written in Haxay, and basically I'm calling the Haxay standard library. There's a file system module in there, and I call exists because this function wants to see if a file exists, okay? Very concise code, very readable, written once, runs theoretically on any processor. So I created a proof of concept because, okay, I've got my type mappings, I've got my function type mappings, I've got an implementation of a file module, but actually is it going to really work inside a processor in the real world? So I've been an exist hacker for many years, so out of pure knowing the code base, I decided to try and get exist to talk to this thing. Okay, because I know how to work with exist. I could have done it in basex probably, but it would have taken me a lot longer. So I added support to exist for talking to my implementation type mapping, my function type mapping, and I was surprised how easy it was. I basically did it in about an hour at the end before my paper had to be submitted to Charles. So I ended up with about 300 lines of Java code, which for me, that's pretty good. You obviously have to map, exist has its own concept of XDM types and function types, so I have to map those onto the interfaces in Haxay. There's lots of different ways you can do this. I talk about several mechanisms for this in the paper, but I used a mixture in exist just for pure convenience of bytecode generation and some static mapping as well. So some of it's dynamic and some of it's static, but it all hangs together. It's a bit of a hack, but it's kind of sweet. So Yeah, the code is available. It's on GitHub for both of the parts. So there's all of the Haxay stuff that's on GitHub. The file module is in Haxay, that's on GitHub. Exists implementation to talk to it is on GitHub. You can go and have a look at this stuff. So, conclusion. I used Google and I found some magic. No. So I now have the ability to implement extension functions just once, okay? So if somebody creates a standard which says, okay, here's some extension functions, this is the standard for it, they can now also go and express these in Haxay. And it means anybody can download that source code, compile it for their processor platform, plug it in, and off you go. And you only have to implement the XDM types once, okay? So if you go and implement the XDM type mapping and the function type mapping, the EXPath project or whoever can pump out as many standards as they want and implement in Haxay, and it's just going to work. Okay? There's no more work required. You don't have to implement for every module that's produced. So I just want to do everything once, and I've found some crazy way to do this somehow. And I think it's pretty promising. It needs some more investigation. So this is how I basically see it. We have extension functions in Haxay in the end. We have processors that implement whatever, and they just work. Okay. Thank you.
That was truly awesome. It was.
Okay.
Do we have any questions? No.
All right. So how do you handle exceptions? Do you handle exceptions in Haxay or in the target?
So by exceptions, I assume you mean XPath errors?
Well, let's say this example of file exists. If the file does not exist, what happens?
Okay, so the EXPath module for file defines whether you return an XPath error or you return like Boolean false, right? In terms of file exists, you return false. If the file doesn't exist, there are some conditions where you return XPath errors and error codes. But again, they're just implementation type mapping. So you just create a type in Haxay that represents that error code, and you pass it. So it's just the same as returning a value.
Standardized, right? Or
Sorry?
So this could also be standardized? Or
Yes, absolutely. Yeah, it's in the type mapping. So.
FYI, you were saying about the biggest vendor of XQuery
Yes.
implementing these things and so on. And so
Yes.
forth. I forgot which version of Mark Logic it is, but they brought in this ability to create custom functions,
Right.
but in C++.
Yeah, so Mark Logic has user-defined functions, which you can write in C++, but they're very limited, I believe, and Norm, correct me if I'm going wrong here, please. They're aggregate functions. So you can't create a general purpose XPath function. It has to be a function that iterates over the indexes in Mark Logic to produce a result.
That's a shame.
They run the DNOs.
Sorry?
They run the DNOs over the indexes.
Thank you. Michael.
If you want to write, for example, a SQL extension
Yes.
to SQL databases, am I right in thinking this approach is dependent on Haxay having support for SQL in its library?
Yeah, absolutely. So the trade-off is Haxay's standard library, okay? So if you write this and you want to talk to a SQL database, does the Haxay standard library have a SQL module or functions, okay? In terms of SQL, yes, it does. That's there. So that's very doable. But say any other case, you have to go and see, does it exist in the standard library? If it doesn't, there's nothing to stop you actually writing that for Haxay and putting it into their standard library. Haxay is an open source project. It's quite a good community. I've been dealing with them for a few weeks now.
But you then have to write mapping to the JDK version and the C.
No, not necessarily. I'm not quite sure how the source-to-source compiler is done, but I think they go to an abstract syntax tree in the middle, and then people basically implement that abstract syntax tree in a compiler, source compiler, right? They're producing source code. So I think if you want to do something very, very specific, like you want to make some sort of low-level system call, then yeah, you're going to need to know how to do that in C or the Java version or whatever. But if it's fairly higher level stuff, say, then yeah, you can implement that in Haxay and it will just be compiled to the appropriate source code. So. Yeah.
Oh. If I remember correctly from Haxay, it's the source-to-source compiler, right?
Yep.
But it is from Haxay into other languages. So if I have a processor and I've implemented a lot of extension functions for it over the last couple of years, for instance, and I want to use HAXE interface,
Yep.
then that requires me to rewrite those functions, because you can't simply take the Java or C# code and turn it into HAXE. You just first have to rewrite it by hand into HAXE, and then you can cross-compile it into C# and Java.
Yeah, absolutely. However, I mean, so I can only speak about Exist because that's the only process that I'm involved with. I mean, we have a standard, extension module library of something like 55 modules now, lots of functions in. I'm not proposing that I'm going to go and rewrite all of that in HAXE because it's done, okay? But the EXPath project, which is producing standards about extension modules, there's no reason why these new ones that are coming along shouldn't be just implemented once, okay? So I don't have to go and do it. Christian from BaseX doesn't have to do it. Mike or O'Neill from Saxon doesn't have to go and do it, right? One of us can say, okay, we're going to do this, and we can all share it, okay? But the point is really that if you have a standard and it's not adopted, okay, your code isn't portable, right? So you have to have a standard and it has to be adopted. So what I'm trying to do is reduce the barrier to adoption for an implementation, okay? Vendors don't have a lot of time, they're all busy, they're going in different directions. If I can implement something once that every vendor can use and there's a standard for it, I've gained critical market share, okay? So my code is becoming more and more portable because I'm not using vendor-specific extensions.
Yes, in some cases, I think your extension function will want to have access to the data model itself from the existing document. Don't you have to code this interface as well?
The data model, so you mean the XDM?
Yes.
Yeah, of course. So the XDM type mapping, I only showed Boolean and XS string, right, which are simple atomic types. But yeah, of course, I need interfaces for node, element, attribute.
You may want to evaluate an XPath expression, for instance.
That would be done by the processor, passing the stuff through to the function, would it not?
Yeah, I mean, this is just the types, okay? So I'm not trying to write a processor in HAXE. I'm just trying to create interfaces that an implementation can pick up. So maybe I'm not quite understanding your question.
I just think that early first, for instance, I had also this idea in mind that if you want to get the line number information, for instance,
yeah,
that may be, now you may cast the object model to the implementation and then get that information.
I mean, if you want to get a line number, okay, you're going to look at the abstract syntax tree that the processor is processing. So if you say, can I have an xquery function that asks the processor what is the line number from the abstract syntax tree, that's hard.
The line number of a node in the source document.
Mm-hmm.
Yeah, okay.
Which is
I don't have an answer for that.
It's a function that isn't in XDM.
Yeah, so I'm only mapping XDM and function interface, basically. So anything outside of that, I haven't thought about. So.
Yeah, but you can propose, an API that the processor can implement.
Yeah.
With SVM model.
So there's a very fine line, and I talk about this in the paper a little bit, about how much you want to impose on a processor, okay? Because I want adoption. So if I impose too much on a processor, people are going to shy away from implementing this, okay? It has to be easy for people to do, or they won't do it. So I kind of don't want to mandate too much. I think XDM is okay, but there's a trade-off. Do I implement them as classes with some concrete methods, or do I just provide interfaces? And sometimes it makes sense to do one, sometimes it makes sense to do the other, but you want to keep it very lightweight. So.
Okay.
Thank you.
Thank you, Adam. Thank you.